Welcome to Random Maths and welcome to the fifth and final video in the Finite Series playlist. In this video we'll be discussing the mathematical model behind mortgage loan repayments. So let's take an average couple with two children. Both adults work full time, with the woman earning £28,000 a year, so £28,000 a year, and the man £41,000 a year. Let's also say they have £50,000 saved in the bank. So just through saving their money and spending wisely, they've managed to save a total of £50,000. Now let's say they want to purchase a property valued at £250,000 in order to raise their children. So since they only have £50,000 in savings, so the property is valued at £250,000 and they've only got £50,000 in savings, they're going to need a loan of £200,000 because you take the cost of the property, which is £250,000, we're going to take off what they can put towards it, £50,000, so they need another £200,000. So they're going to go to the bank, and the bank will agree to a loan. Since they have 20% of the value of the property, £50,000, which is 20% of the value of the property, as a deposit, and they've got two stable incomes, the bank will offer them a 30-year mortgage, so a 30-year mortgage, with an yearly interest rate of 4.2%. That's what the bank's going to offer them as a mortgage. So the loan is going to be what's called a mortgage. So this £200,000 loan towards a property over a long period of time, say 30 years, with an interest rate, a low interest rate, is typically what we define a mortgage to be. It's a large loan that people take out over a long period of time, being a repayment loan, and it's usually towards a property. Well, it's always towards a house or property. So this is the definition of a mortgage, and this is essentially a mortgage. So that's that out of the way of. So how it works is as follows. The bank was going to set a time frame for which the loan must be paid back, which I've already stated, which is 30 years, and also a yearly interest rate to be applied each month, in this case 4.2%. The result is a set monthly repayment amount, and that's linked to this yearly interest rate of 4.2% and the time frame it is due to run for, so it is 30 years, it's a 30-year mortgage. Okay, can the couple wish to renegotiate terms of the loan? They can. So the interest rate may change. It could be on a variable interest rate mortgage, which means that say after the first 5 years it can vary year on year, depending on the Bank of England interest rate, or if you're in America, the Dow Jones interest rate, or the Federal Reserve interest rate. I'm not sure the financial institutions over there that it can be based off of, but it'd be some arbitrary figure that it would be based off of, and it can vary depending on what the value of that figure is. However, for the purpose of this video, we're just going to assume the interest rate is fixed for the duration of the loan, and the time frame for which the loan must be paid back does not change. We'll go over what happens when the interest rate changes at the end, but yeah, for now we're going to assume they're going to be fixed. So let's begin. In order to actually, we've got everything here that we need in order to calculate the monthly repayments that they're going to make over this 30-year period. But in order to find out what that monthly repayment is, we need to do a bit of maths to understand the model behind the whole mortgage loan repayments, and that's what we're going to be discussing in this video. So the repayment rate at the moment, so we're going to define some variables, and we're going to define the model at the minute. So just before I begin, we're going to define some variables, mathematical model, and we're going to define some variables. So if you bear with me just one moment. So we're going to say P. It's usually called the what's it called? So P is called the principal amount, and that's the principal loan. So that's the initial loan, amount, or we're just going to call it the value of the loan, or the value of the mortgage. Now we're going to set little r to be the interest rate. In this case, so the principal in this case is going to be equal to £200,000. The interest rate in this case, I'm going to say, or I should say yearly interest rate, because it's always given as a yearly figure, even though it's not. They should really give the monthly figure. I'll explain that in a moment. So little r is going to be the yearly interest rate. Then we've got n, which will be the duration of the loan in years. And then we're going to have m underscore I, to be the amount owed after month I, or the amount outstanding and that's going to be for I is equal to 0, well, we're going to say 0, 1, 2 to 12n. 12n because that's going to be the last month. So if you've got 30 years, the last month is going to be 12 times 30. So the 360th month, I believe that is. That will be the last month, because you've got 12 months in a year. Multiply that by 30, and then so that's why it will be that. So it'll be 360th months. After 360 months, you will have paid back the loan. And then we've got the last and final term, which we don't know yet, which we're going to solve, which is R, which is the monthly repayment amount. So that's what we're doing in this video. We're going to determine what the monthly repayment amount is. So the monthly repayment amount. Okay, so let's begin. So we've defined these variables. Let's begin with our example. So I'm going to do the example on the left, which we were given above, and I'm going to do the general case to the right. So let's begin with the example. So I'm going to begin with the example to the left and the general case to the right, but we're going to begin with the example. So what happens is each month, so I'm going to just say M0 is going to be equal to the principal amount, because after the 0th month, or before the mortgage even begins, the amount owed is the amount we took out for the mortgage, so £200,000 is owed initially. M to the 12n has to equal 0, so M underscore 12n as this has to equal 0, and that's because after on the last month, after the last month, we owe nothing. We've paid it back. That's why it's a set period of time. This model will guarantee that after the last month in the time period, we're to pay back all of the mortgage back, all of the capital of the mortgage left. So there'll be no interest to be applied after this month, because there'll be nothing left outstanding, because the interest is only paid on the outstanding amount. So I'll give you an example. So go over the example now. So month 0 is just what we owe is £200,000, and then what happens going forward. By the way, so the yearly interest rate is 4.2%. So the monthly interest rate is going to be 4.2% divided by 12%, because we're going to apply the interest monthly, because the repayments are done monthly. The interest is going to get applied monthly. It's a yearly figure they give, but it's going to be applied monthly. It's like if you've got a job and you're earning £20,000 a year, for example, or let's make it easy, £24,000 a year. You'll be getting, before tax and insurance, obviously, you're going to get a lot less afterwards, but you'll be getting £2,000 a month. But they're still going to give the value of your salary, of your wage, as £24,000 a year. So it's the same kind of principle here. We've got a yearly interest rate of 4.2%, but the monthly interest rate is just going to be 4.2 divided by 12%, which is going to be equal to 0.35%, which obviously it's basically this as a decimal figure is going to be 0.042, 4.2%. Go back 2 decimal places, and this is going to be 0.035. So no, it's going to be 0.0035, I believe. So let's have a look. 3.5%, 1, 2. No, so it would be 0.035%. So that's poor mathematics there. It's embarrassing. So you divide by 100 to get it back as. Oh no, sorry, no. Jesus Christ. Yeah, it will be 0.035% because this is here. Go back 2 places to get there, so sorry, yeah. Apologies for my poor mathematics there, but that'll be 0.035%. 0.35%, which is 0.0035. So that's going to be the monthly interest rate. Apologies for the failure in my maths there. Hopefully there shouldn't be too many more errors. If there is, I wouldn't have made the video, I would have restarted by now, but yeah, so that's going to be the monthly interest rate. Nobody's perfect, so, you know, apologies for that. Right, so 1, 2, yeah. Okay, so in month 1, what we do is we need to find out we take the amount owed. So this is going to be the amount owed. So we're going to take have to take deductions and additions. So we take the interest is going to be £200,000, £200,000 multiplied by 0.0035. That's going to give us 0.35%. So that's going to give us the interest, because we've got to pay interest of 0.35% per month. So that's what we've got to pay as interest. So if we do the calculation here, I've actually got a calculator, so we'll pull that up now. So we do £200,000, 200,000 multiplied by 0.35%. So we get £700 interest. Is going to be our first figure. Then we're going to take off. So we're going to take what we owe, and we're going to take off. So we're going to take what we owe, which is, so that's the interest. So we owe £200,000, and interest is that, and repayment monthly. Our monthly repayment is £R. So what we're going to be doing, so what we're going to owe, this is M1. So what we're going to owe after 1 month is we're going to take our £200,000, so plus the interest, so £700, minus the monthly repayment rate, which we don't know. That's what we're going to have. That's what we're going to owe after 1 month. This. Another way of writing this though is as follows. So £200,000 is just £200,000 times by 1. £700 is just £200,000 times by 0.0035. So this can be just defined as the following: £200,000 times by 1 point plus 0.0035 minus capital R, which is just equal to £200,000 times by 1.0035. That's just what's in this bracket, what this bracket is equal to, minus capital R pounds. So that's after 1 month. Pretty straightforward, pretty easy. There we go. Now generally, rather than this, if we didn't have figures for this, we'd do the general example. So this is an example. Now generally speaking, let's do the general case after 1 month. What happens? So we've got the yearly interest rate is R%. Yearly interest rate. So R is going to be R%, which is just going to be R as a capital. So the yearly interest rate is R as a decimal. As a fraction, it's going to be, or 100R%. So 100R%, but we're going to, the R here, so this is going to be the decimal value, not the percentage value, because R times 100% is just R as a decimal. So 4.2 divided by 100 is as a decimal is 0.0042. So the yearly interest rate is 100R%, which is just R. Monthly interest rate is just going to be R divided by 12. It's divided by 12. The decimal, so we've done, in this case we did, this is just 4.2 over 12. So this is just R divided by 12. And we're gonna owe initially, so M0, we're gonna owe P pounds, the principal, and in the example it was £200,000. Generally we don't know because we've got no figures in mind, we just do in a general case, it's just going to be P pounds. So M1, what we're going to have is we're going to owe P pounds, capital P pounds, or the principal. The interest is just going to be whatever the P is, P pounds, multiplied by R over 12, whatever that is. That's going to be equal a value. We can't say equals 700. We don't know what this is, so we have to leave it like this. And then we've got the monthly repayment, which we still don't know. This is an unknown variable in both instances. We're trying to find that out in both instances, given initial conditions of the principal amount owed and the yearly interest rate. So the monthly repayment is still going to be capital R. So M1 in this case is just going to be equal to P plus P times by R over 12 minus capital R, which is just going to be factor out the P times by 1 plus R over 12 minus capital R, which is just equals, to be honest we can even factor out the pound sign, just do P times by 1 plus R over 12 minus R. So we could have done that here as well, we could just do equals £200,000 times by 1.0035 minus R, capital R. So we can do that here, and we can just going to say M1 is equal to this, and that's how much we owe after 1 month. Okay, so what do we owe after 2 months? So, because we need to spot a pattern here. I don't really spot a pattern just yet, but we kind of get into a pattern. Okay, what do we owe after 2 months? So let's look at the example case again first. So M2, well what we're going to do is we're going to take what we owe from the last month. So what do we owe at the moment? Well, we owe £200,000 times by 1.0035 minus R. So we owe, that's what we owe at the moment. So we owe, so we've got to take the interest on what we owe. So we don't know what we owe at the moment because we don't know what the repayment rate is. So it kind of gets a bit tricky, but we can do it. We can find out the repayment rate based on this model. So we need to apply the interest first. So what we owe, so let's just do it again as formally as we can. So what we do is we're going to do a little M2. So we owe, currently we owe, because last month what remains, the amount payable after, the amount owed after 1 month is going to be, it's not going to be £200,000, it's going to be £200,000 multiplied by the add the interest on, take off the monthly repayment. That's what we're going to owe, and we're going to say the interest, and then the interest on this is just going to be this whole thing. So £200,000 times by 1.0035 minus R. So the interest on that is we're going to multiply that by 0.0035 to get the interest on that. And then M1 therefore is going to be equal to M2, sorry, M underscore 2 is going to be equal to. So let's have a look what that's going to be, what that means. Yeah, in a minute we'll have a look at that. So we're going to have to add both of these together. What we owe plus the interest. We've got a common term, which is this. So again, what we've got is we've got £200,000 times by 1.0035 minus R multiplied by the common term 1 plus, so 1 plus this again, so multiplied by again 1.0035, and then again we need to minus what the repayment rate, so we've got monthly repayment R, so we're still going to be taking off the same fixed monthly repayment. So we're going to do that here, so minus the monthly repayment of R pounds. So what we actually have is £200,000 times by, and then 1.0035 squared minus capital R times by 1.0035 minus capital R. We can factor out these R's now, because why not? So we're going to have £200,000. Kind of starting to see a pattern. Times by 1.0035 squared minus capital R times by 1.0035 plus 1. But let's get it all in terms of 1.0035. So let's just do 1.0035 to the 0, because that's also equal to 1. So that's going to be 1, and that's going to be 1 here is equal to this here, because anything to the power 0 is 1. Okay, nothing wrong with that. Okay, and that's going to be M2, and we're going to put this in blue, so there's nothing wrong with that. Now let's look at the general case again. So we've done the example case here, let's look at the general case. So it's going to be pretty much the same kind of principle. We're just going to look at the general case over here, so we're going to look at what does M underscore 2 equal. So we're going to owe P times by 1 plus R over 12 minus R. What we're going to owe the interest is just going to be, we're going to add on the interest to what we already owe. It's going to be just P times by 1 plus R over 12 minus capital R, and we're going to multiply that now by R over 12. That's the interest factor. And we've already got a monthly repayment R that we're going to be paid back this month, so we need to take that off, because we've added the what we owe plus the interest minus what we're going to pay off. So we're going to take what we're going to pay off. So what we've got is we've got M2 is equal to the same kind of principle as before. So we're going to just have, again we've got, we can add these to common factor, so we can add both of them together again, as we did in the other example. So what we've got is I'm going to skip a step or two maybe now, just to speed it up a bit, the video. Minus R times by 1 plus r over 12, and then we're going to minus the repayment because we're going to make that every month on a common repayment. Multiplying it all out, what we're going to get is the same kind of thing. We're going to get p times by 1 plus r over 12 squared minus r pounds times by 1 plus r over 12 minus r pounds, which is equal, so we've got m2 is equal to p times by 1 plus r over 12 squared minus r times by 1 plus r over 12 minus 1 plus r over 12 to the 0, because again anything to the power of 0 is 1. So just in case you're getting confused why I've added that. I've added that term in for a reason rather than writing it as 1. Just so you've got common terms that we're going to be adding together. And we're going to put a plus in here because the minus is done outside. And that's our general case for M2. Now all we're going to do is we're going to do one more and we're going to do M3. And after M3 that'll be enough to see a pattern. And we're going to use that pattern then to give a generalized form, and then we can find out what m underscore 12n is for the last payment, the very last payment. And then once we've done that, we'll be able to see what's going on with this stuff. So bear with me just a moment. So we're going to do M3 now. So M3 is going to be the same kind of principle. So essentially what we're doing here is, if you've not figured it out already, we're taking m underscore I is going to be equal to m what we owe in the previous month times by the add the inflation on, so 1 plus r over 12, take off the monthly repayment rate. So that's that's the model, because that's what we've done here. We've taken that here because M2 here is M2, that's going to be M1, sorry, that's M equals M1. We've multiplied by the monthly inflation rate, and then we've taken off R. That's the model we're using, but we're going to get a nicer form for this blue thing in this box here. It's the same thing here. We're taking the monthly M1, which is that M1, multiplied by the inflation, and then taken off the monthly repayment rate. And obviously that's going to be the case for M2 as well if you follow this pattern along. That's what we're going to do here. But we're going to get a nicer form for it. So we're going to do M3, sorry, not M2, M3. So what we owe, we now owe this whole horrible thing here, which we're going to just call M2, which is equal to, so we always owe, so this here is M1, that's what we owe. And what we owe the previous, what we currently owe. So we're going to take £200,000, let's just do it quickly, times by 1.0035 squared minus capital R. Now what I'm going to do is I'm going to use a summation notation. Actually no, we won't use summation notation just yet, we'll use that in a moment. Sigma notation, sorry, shall I say. Minus R times by 1.0035 plus 1.0035 to the 0. So the interest in this case is just going to be, I'm going to take what we owe, M2. So M3 is going to be take what we owe, M2, add on the interest, so 1.0035, take off the monthly repayment, so we're going to do that. So the interest is just going to be, so this is kind of at the what we owe plus the interest, and we just put it as this factor over here. We add the factors up to write it as one line rather than two lines, but we'll do it as two lines, one more, because it's going to be the last time we do it anyway. So what we take is the M2, what we owe, times by, so let's have a look, what we owe, this whole thing, minus capital R times by 1.0035 plus 1.0035 to the 0, and then big capital, so that all this multiplied by 0.0035 minus, and that's the interest. So again, just add the things together, what we get, and we've got the monthly repayment as still going to be our pounds, which we're trying to figure out. So what we have is we're going to have M3 is equal to, and this will be, you'll see a pattern here that'll form £200,000 times by 1.0035. So we're going to multiply that. Yeah, we'll do this quickly first. Squared minus capital R times by 1.0035 plus 1.0035 to the 0 times by all of that in big brackets times by 1.0035 minus capital R. So then what we get is we get £200,000 times by 1.0035 cubed, and every one of these is going to get multiplied by this, so we're going to have minus capital R times by 1.003, so everything in the brackets is going to get up to 1, index is going to be up to 1, so 0 plus 1 is 1, 1 plus 1 is 2, but then we're going to also minus again an R outside the bracket, so we're always going to take off an R. So factoring out all the R's and everything else, what we get is we get M3 is equal to £200,000 times by 1.0035 cubed minus capital R times by 1.0035 squared plus 1.0035 plus 1.0035 to the 0, as so. That's going to be M3, and we're going to actually just skip the general case now. I'm not going to go over the general case again, but it'll be the same because the method's the same. We're just replacing 200,000 with P and R over 12 with 1.001 plus R over 12 with 1.0035, but other than that, everything else, all the operations we're going to be doing are identical. So what we'll get in the general case is we'll just get M3. I'm not going to do it, we'll just put dot dot dot. All we're going to get in the general case is M3 is going to be equal to P times by 1 plus R over 12 squared minus capital R pounds times by 1 plus R over 12 squared plus 1 plus R over 12 plus 1 plus R over 12 to the 0. Okay, so that's the general case. So the pattern is, let's have a look at the pattern. Can we spot a pattern? So let's have a look. So we've got M2 here, M2 here, and then we've got index 1 less for all of the ones in the brackets multiplied by the R. So 2 minus 1 is 1, 2 minus 2 is 0. So we've got an index of 1 less. And we've got the same thing going on here. So we've got 3 here, 3 here, and then we've got 1 less in all the indexes here. So it's just the same kind of principle. So what we can say is if we carry on, all we're going to get is 4i, so M, so generally we're going to have M underscore I is going to be equal to 200,000. So so ith term in the example we're just going to have M underscore I is 200,000 times by 1.0035. So this 3 here matches the 3 there, so this is going to be just I up here. And then what we're going to do is we're going to take off capital R And so how we sum the second, so we're summing everything from 0 to I minus 1 here, or to 3 minus 1 here. So in this case, we'll have 1.0035 to the I minus 1. So that 2 is 1 less than the 3. This I minus 1 is 1 less than the I. And we're going to sum up, so we're going to have 1 less than that, so we're going to have 1.0035 to the I minus 2 dot 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 times by 1.0035 to the 0. Ith term example, so then we're going to have ith term general. So this is the general case rather than the example with the £200,000 in. What we're going to have is we're going to have m. Before I do that though, we're going to actually put in use a sigma notation and simplify this a bit further. Or we can say mi, for the example, is going to be equal to £200,000, and we've got a sum now in this bracket, so this here is a summation, and we already know what this is. It's a geometric series. We looked at it in the last video, and that's the whole point of the last video. We need to know what a geometric series is to get the generalized results. So we're going to look at that now. So this is minus capital R times by the sum from, so what we're going to use here for the sum is we're going to use the dummy variable here as a variable that we've not used as of yet. So I don't think we're going to use j. So from j is equal to 0, because that's going to be our first term, 0 here. And the last term is going to be I minus 1. So j equals 0 to I minus 1. The j is a dummy variable, it's not going to get used. It's only going to get used to fill in values for j, to give us return as what's in the bracket above. So times by 1.0035 to the j, to the j. So 0, so that's going to be j equals 0, 1.0035 to 0, plus j is 1, plus 1, all the way to I minus 1. So the ith term, generally, in our so rather than the specific example with 200,000 and 4.2%, the ith term general is just going to be the same. I'm not going to go through the 2 steps here, I'm just going to do the 1 step. And I'm just going to skip this kind of bracket step at the top. mi is equal to, well, p, the principal amount, that's going to be what 200,000 is, times by 1 plus r over 12, depending on the interest, to the I minus capital R times by the sum from j equals 0 to I minus 1 times by 1.0035 to the j. However, I should have left a gap between this actually, because however we know what this figure value is here. This value is a geometric series, and so is this value a geometric series. So if you look how to solve geometric series, in the last video we had the following solution. We had the sum from j is equal to 0, let's have I minus 1. We're going to use j as a dummy variable, and we had like x to the I, the j, sorry, and we had that this was equal, so we had this will be equal to essentially so this would be equal to x to the I minus 1 all over x minus 1. In the previous video we didn't have we had different variables, so in the previous video, look in the red here, in the previous video it would have been in the form of, I think so we'd have used r probably, r is equal to 0 to n minus 1 I'd guess, and what we'd have done is we'd have done x to the r, and that would have been equal to x to the n minus 1 over x minus 1, but we're just changing the dummy variable, so n minus 1 to I, so x to the n is now going to be x to the I, and then the j and the r is the same thing. We haven't used r in this case because we've already used that for the inflation, the yearly inflation decimal figure. I don't want it so redundant, it's a variable we've already used, that's why we're using j instead this time. But that is just taken from the result from the previous video in red. If you want to know where that came from, watch the previous video on geometric series, I prove it. Okay, so essentially what we can say is we can say so what we can say for the example, we've got M underscore I is equal to £200,000 times by 1.0035 to the I minus capital R times by, so we're going to look at this, compare it with this. So x is now 1.0035, and that's the only thing that's different. So we've got 1.0035 to the I, 0035 to the I, minus 1 divided by 1.0035 minus 1 in brackets at the bottom. So general, that's for I is equal to, does it hold with a 0 term? 0, no, it doesn't hold for 0. That's for equal to I is 1 to 12 to the n. It doesn't hold for 0, and obviously M0, because if you put 0 in, it kind of does hold for 0, because it's going to be 0. Yeah, it does hold for 0. So in fact, we can put 0 as well in. So it holds, so that's going to be just 200,000 times by 1, and that's going to hold the R minus R times that whole stuff is going to cancel, so it holds for 0 as well. So that's for the example. For the general case, when we take 200,000 for P, and R is for 4.2% and all that, what we're going to get instead is, so we're going to get M underscore I is equal to P times by 1 plus R over 12 to the I minus capital R times by 1 plus R over 12 to the I minus 1 divided by, so this here can also be written as just 0.0035, and this here can be just written as 1 plus R over 12 minus 1, or just R over 12. So this here, so is also, so this, I'm going to rub it out now, but this is just 1 plus R over 12 minus 1, which is just equal to R over 12. Kind of skipped a step, I hope that makes sense, that's why it's just R over 12. We're going to rub that arrow out now because it's in the way. So we got that and that, so we're writing in blue. That's the general form when we haven't got particular values, and this is the form otherwise, and that's just going to be for both of these. Yeah, 12 to the end is going to be the last term. So now we can actually work out what R is going to be equal to, and we can do that. We can't do it when M is 0. We know that's going to be P, but when R cancels out in that case and disappears from the equation. But we know that after the last month, we don't want to owe anything anymore because the loan is set for a particular period. So this mortgage is going to go for 30 years. After 30 years, it's supposed to be paid off. So if we look at M to the 12M, what we're going to see is, so M to the 12, so M to the 360. So in the example, we're going to have because 12. So the 360 months is 12 years, right? 12 times 30 is going to be 360. So M to the 360 equals 0. So what we have is M to the 360, which is equal to 200,000, right? Times by 1.0035 to the 360 minus R, capital R, times by 1.0035 to the 360 minus 1 divided by 0.0035 is equal to 0. So what we can do is we can rearrange this equation. We've got a capital R now, times by 1.0035 to the 360 minus 1 divided by 0.0035 is equal to 200,000 times by 1.0035 to the 360, and then we've got our pounds here is equal to 200,000 times by 1.0035 to the 360, all of that divided by all of this, 1.0035 to the power of 360 minus 1 divided by 0.0035. But then this is just going to be equal to, so we can flip, when we're dividing by a fraction, we can flip the fraction. So it's just going to be, simply put, we're going to have £200,000 times by 1.0035 to the 360 times by 0.0035 divided by 1.0035 to the 360 minus 1. That's going to be what our capital R is equal to. Generally speaking, so rather than the example, we'll do generally speaking. I'll find out what this is in a minute, but generally speaking, what we're going to have is the same thing, but we replace 200,000 with P and replace 1.0035 with 1 plus R over 12. Generally speaking, we're going to have capital R. I'm not going to do the steps here and such because this takes a while. So M12, M to the 12n is going to be equal to 0. So we can place 12, so 12n, so 360 is equal to 12n, 200,000 is equal to P. The actual process to get there is going to be the same, and then 1.0035 is equal to 1 plus R over 12. Other than that, everything else is going to be the same. So what we're going to have is capital R times by P times by 1 plus R over 12 to the 12n times by R over 12 divided by 1 plus R over 12 to the 12n minus 1. Okay, so in our example, capital R is equal to, as I've already done it, it's just going to be down here, but we're going to write it out just once more. So £200,000 times by 1.0035 to the 360 times by 0.0035 times by 1 plus 1.0035 to the 360 minus 1. And now this is equal to, so we can use a calculator for this because it is quite difficult to do without a calculator, but we can use a calculator for it. And we can program it into a computer to easily do it. So what we're going to have is we're going to take £200,000, £200,000. We're going to multiply by 1.0035 to the 360. Then we're going to multiply by 0.0035. Then we're going to multiply by 1.0035 to the 360. Then we're going to take away 1. And we're going to get £978. And, well, we're going to say 3p to be precise, or £978 to nearest pound. Okay, now if you don't believe me that I'm correct in this, let's see, if I've been talking complete rubbish in this video, then Google will give a different value. So let's have a look. So what does Google give? So Google uses the same equations that I've calculated in order when it does it. So you took mortgage loan calculator in Google. If you're in America, it probably come up with dollars rather than pounds, but I digress. Put in the amount. So we wanted a mortgage loan of £200,000. So we've got £200,000, 4.2% interest rate, and we wanted a 30-year mortgage. So there you go, £978. It's rounded to the nearest pound, so it's actually £978.03. It's come to 352,092 because it's took the total cost of the mortgage, and it's multiplied it by 360, the number of months, because that's 360 monthly payments in order to pay off the mortgage. So that's what it's done. So if we look here, we're going to take 97. So let's write it a bit more accurate. So we're going to just do 978.0. So what do we have to do to 5 decimal places? Well, it's going to be 3 pence a month, isn't it? Because you're going to have to pay it monthly. So it's going to be multiplied by 360. That should equal, I'd imagine, what they've got. 978. That's going to be the total cost of the mortgage. So times by 360. Yeah, so that's 352,090.8. What they've got on more in there to 0. So they got 092. The reason is they've done it more accurate. So essentially, that horrible figure, I'm not going to do it again, but it's not quite as accurate because they've not used the. If you round to 5 decimal places, it will be more accurate. So what Google has is of 352,092. I've got 352,090. That's actually correct because you can't have 0.03 to whatever it is per month. You need to round it to 2 decimal places because that's what you're going to pay each month. You can't pay less than that. So that times 360. That's essentially what it's going to total cost of the mortgage is going to be 352. What was it? 090.80. 090.80. But if we didn't round down, we'd get 092. So we'd have an extra £1.20 if we didn't round down. But never mind, we did. So that's the total cost of the mortgage. Okay, so essentially the bank. So if you did this, took this mortgage out, and you had a fixed rate. So we've got the equation now for all of that, and we know the model now. But if you took a mortgage out, the bank would have made in profit over the 30 years. So profit for bank, naive profit, because the bank's going to be reinvesting this money. You're not just going to leave it sat in the bank. But a naive way to think of the profit for the bank is just going to be, we'll use the main figure that Google used, 352,092. It probably will be that, because what they'll do is, like the last month or something, if they'll just find out you'll pay a bit more in order to make it, so you pay an extra £1.20 maybe in the last month just to cancel out all the debt to make it all work and be exact. But profit for the bank is going to just be 352. So we're going to use the figure on Google, 092 plus the £1.20, it doesn't matter, minus 200,000, which is going to be 152,092 pence after inflation, maybe. So £152,000 today in today's money, maybe in 30 years' time, is only worth 80,000 or 70,000 or whatever. But the bank still made a tidy profit. Plus, they'd made even more than that because they'd have invested the money as you were paying it back through maybe a mortgage-backed security, or maybe they just take the money that you pay and they'll put it into other stocks and bonds and shares. So the bank's going to be making a lot more than the £80,000 But an initial kind of naive way of looking at it, if you pay the money back and they put it in another bank account and leave it there and don't touch it until you've paid it all back, maybe after inflation it comes to about £80,000 they've made. So they're making money off you. The couple, the family we were talking about earlier, can live in that house for 30 years whilst they're paying it off, raise their children, grow old there, live there, have a good time there. So they kind of win out the situation because they get to live in the house. At the end of it, they've got an asset to their name. The bank wins because it makes money. Everybody wins. The only time everyone doesn't win, any time the system falls apart and people don't, the bank loses out and the people lose out, is when they can't afford to pay back the monthly repayments. So this £978, when they can't afford to pay it back and they default on their mortgage, then there's an issue. And what the bank will do as well is they obviously leverage the value of the property against what the loan is as additional security. So you give 20% of the deposit anyway, and then the rest of the value of the property goes towards the security blanket of the bank. So if you sell it for, even if the value goes down, as long as it doesn't go down by more than the deposit amount, they're kind of still okay and they can pay off the loan. If it goes down by a lot, the value of the property, which did happen in the financial crisis in the US, the property prices plummeted. They couldn't afford, so they defaulted on their mortgage. So the bank had to sell the mortgages back. So forget the securities for a minute. The bank has to make them sell the property, but the property is going to be selling in negative equity, so you're going to be selling it for much less than what you borrowed. So then the bank's out of pocket, you're out of pocket, everyone's out of pocket, you owe a debt to the bank can't pay back its creditors and stuff, etc., etc., and it gets worse as well. Watch the movie The Big Short, because they were giving mortgages to people who really shouldn't have been getting mortgages. And what they were also doing is they were selling off mortgages, and the reason they were doing that is they were selling off more mortgages as securities. So they'd lump it all into one big security. The bank will sell it all off and divide it into many different pieces of paper, different pieces of security and equity, sell it all off. The bank would make all the money that they would make a massive profit straight away off these mortgage-backed securities, and essentially there'd be no risk for the bank because they sell it off as a security. They've received all the money at once, which is a bigger in profit because there's no inflation involved because they sell it off on the day, and they just pay out the people who hold the securities as the people who owe the mortgages pay back their monthly repayments. So the bank's happy, everyone's happy. The only problem is the investment side of the bank was buying these mortgage-backed securities. The retail side of them were selling them and giving them to everybody and anybody who wanted one. So whilst the retail side and that were lining their pockets with bonuses and hitting loads of targets and creating loads of money, the investment side of things were buying all these from other banks and other people and creating massive liabilities, and the liabilities obviously outweighed the assets that they were gaining from doing this, and then everybody was doing this and the whole kind of system collapsed because of it. So watch the movie The Big Short. It goes into a bit more detail than that, but that's quite an interesting thing that happened with these mortgages. So yeah, the banks has made a profit. They've made a profit. It's quite a nice thing. But what I will point out is this interest that's growing. You can actually isolate each month. You can isolate the interest, and you can also isolate the capital. So the interest paid each month. So we're going to say I underscore I will be the interest paid. Interest paid each month. And capital C underscore I capital paid each month. So what we're doing is we're saying the interest paid is going to be, in that month, is going to be what's owed from the previous month multiplied by R over 12, right? What was owed in the previous month multiplied by the interest is going to be the interest owed. So that's just going to be, if you want to do an actual formula for it, we know what m underscore I minus 1 is. We can plug it in and do it. But that's essentially what it's going to be. We're not going to plug it in and do it. So that's a quick way of doing it. And then the capital paid is going to be equal to, so whatever the interest is, so whatever the repayment is, minus the amount paid in interest, is going to be what goes towards paying off the capital. So the interest what goes off the payment towards the capital, and I can show you this with an Excel spreadsheet that I made for this. But one thing I will point out is we did this example, before we go on to that, go back into this example, this generalized formula, just to prove to you that it does actually work in all instances. What we're going to do is we're going to change the value here, and we're going to still get the same result in Google, and I'll show you now. So let's say we want to borrow a loan of £178,000. That's going to be our P. Let's say the interest rate in this case is going to be 3.2%. Yeah, 3.2%. So 1 point, rather than, so we're going to do 1 plus, we'll do it properly, 3.2%. So 0.0, let's do it properly, 0.032, it's 3.2%. Yep, divided by 12. To the power, and we're going to say the duration is 25 years. So it's going to be 25 times 12 rather than 30 times 12. Let's just do it in general, so we can plug it in general. Times by 0.032 divided by 12. That's going to be the R over 12 part here, this part. Bear with me a moment. Yep. Divided by, so we're going to have 1 plus 0.032 divided by 12 to the power of, so it was 25 years, wasn't it? 25 times 12 minus 1. So that equals 862.7285 blah 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 877. If we go to, let me just put a bracket around all of this. I like these calculators because you can put the equation in full, rather than if you had a normal calculator you'd have to do step by step, write down the result to 5 decimal places, write down the other result and do it manually. So I like these calculators are quite nice. So we had 178,000, so if we put 178,000 into the calculator for Google, 178,000. We had a 3.2%, yep. And I said 25 years. 863, that's what the calculator got, I believe. 862, again it's rounded to the nearest pound, but it is right, 863. And obviously if we multiply it now, this exact thing, rather than a rounded version, by 25 times 12, so times 25, times 12, we should get the 258,819 to the nearest pound. Yeah, so if we round 818 to the nearest pound, it's 25819. So you can see this is actually the formula that's being used by Google, because it is the actual formula. So it's quite a good method. I'm going to do one more just to really drill it home to you that this is the case. Let's do a 20-year mortgage. Let's change it to, rather than 3.2%, let's say it's 3.6%. Change the figure from 178,000 to 298,000. So we've got 20. I recommend these Casio calculators. You can buy them in the store. They're about £10 in the UK. I think there might be that in dollars in the US. Just so you can put in equations. Really good. So 1743. So let's have a look. If we put in, oh no. Oh, I've actually go up. Somehow I've gone back to what it previously was. I'm not sure how, but we had 173, I believe. So I think we had 298,000. And I think we had an interest rate of 3.6%, if I remember correctly. I don't know what I did to the calculator to get rid of it. And did I say 20 years? Yeah, I think it was like 17 something. I remember. I can't remember exactly. Rewind the video. I don't know. Can we undo tools? I'm not sure. But yeah, it does work. It is the right formula. But let me just show you one last thing before I close this video, because it's gone on long enough. We're talking here about the interest and also the capital paid. So what you can do is you can have a look at this. I Yeah, so I'll show you now. I did an Excel spreadsheet with this. So as you can see, I created an Excel spreadsheet to show the monthly repayments, which was the same as we got in the video, 978.03. Multiplied it by 12, and then by B3, so 30 years gives you the total amount paid. So we've done that part. It uses all the formulas that I derived in the lecture notes. So if I customize a ribbon here, I'm going to open up what's called the developer tab, which is where you can write Excel macros. You'll be able to see, so bear with me just a moment, Excel macros. You'll be able to see some modules here, which is where the functions, some monthly mortgage repayment stuff here. So these are all the functions I created. So the repayment is the same kind of thing, r divided by 12, p times r divided by 12 times by that, to the power of 12 to the n. It's the same formula that I derived in the lecture notes. The amount owed is the same kind of formula as well. So is the interest payment and the capital payment. It's the same thing I've shown you. When they're equal is just solving both of these. We're going to use logarithms. I'm not going to go into that too much detail. But like I was saying about the capital paid and that, if we plug it into the formula, as we can see here, so you paid £978.03. The amount paid in interest is £700. We actually looked at this case when we're doing the example. So this is just going to be the amount owed. So it's going to be the amount owed from the previous month, which is going to be equal to this, multiplied by the, so let's have a look, multiplied by the interest rate, which was 0.035. That's 0.35%, so 0.0035. So we were looking at the amount in 700, which matched that. And we're looking at the amount of interest each month. Again, if we looked at like 697, we just look at the month before, like we did in the equation in the lecture notes. We'd multiply by 0.0035. Was it 36? Sorry, 36 wasn't it? No, 4.2% wasn't it? So no, it's 0.035%, so 0.035, and we'd get 69707. And the amount paid in capital, like I said in the lecture notes, is just going to be equal to the monthly repayment rate, which is, for example, for the 697 case, which will be this, minus this, give you the amount paid in capital. There, I've used a function to do it, but you don't need to look at the function, you can do it like that. So that's how you get all the these figures. I'm going to link this mortgage loan calculator into the as a link in the video description below. Plug in your values here and here. So if you want 300, if you want 200, 178,000, and if you want, was it 3.2% we looked at, I believe, and then 25 years. So it's designed, as soon as you type a duration in here, it will recalculate everything. So once you put 25 in there, the macros will run, as you can see, and it will recalculate everything on the spreadsheet. So you've got 300 months this time, because 25 years, and yeah, it will recalculate everything. But what's interesting to know is, let's go back to the initial example we had. The reason looking at the interest is quite nice to know is because if we look at when we do have 30 years interest, so if we look at the amount paid in interest compared to the amount paid in capital, what you can see is initially we're paying £700 of the first payment, the first 978 payment is just going towards the interest of the loan. It's not going towards the capital, only £278 is. That's quite an interesting thing to note. So if we actually create a little table based on these, a nice little bar chart or chart create on these. If you right click, you'll be able to look at quick analysis. It should be able to look at look at some charts. So you've got a line, or this kind of chart would be nice. So the blue is going to be the interest, I believe, £700, yeah. So I've not specified it, but if you look at this chart here, the blue is going to be the interest, and the grey is going to be the capital. So initially, we're paying a lot more in interest than we are in capital. It's about the month 178, 197 that it kind of equalises out, and then we start paying more off of the capital than the interest. But the thing to point out is when you until you're like so many years into the mortgage, you're going to be paying off. So maybe halfway into the mortgage, possibly in this case, you're still going to have paid off more in interest than you have in capital. So if you give up a mortgage after 5 years, you will not have paid a lot off in the capital. You'd have paid everything off by month 360, but only halfway through you've only paid off so much capital, so you're still going to owe quite a lot, really, because you've just been paying interest off. So if you go to month 155, for example, on month 141, when we're still paying off more interest than capital. So let's have a look at month 141. What you can see here is you still owe 149,000, and the loan was £250,000. No, it was £200,000. So you've only paid off £50,000 of the loan, despite having paid off at this point significantly more than that. So you've paid off from this point 978.03 multiplied by 141. So you would have paid off. You'd have paid 137,000. So in month 141, we'd have taken the 978.03 we pay each month. We multiply that by 141 months. We've given them 137,902 pounds and 23 pence, but yet we've only paid off so in month we're after month 141, so on month 141, well, we'd have paid it on month 141, so we still owe 200,000. We'll still owe. We'd have only paid off £50,000 of what we owe, yet we've paid off 137,000. We paid them 137,902.23 in interest. So until halfway through the mortgage, you're still going to be paying off most of it. You're just going to be paying off the interest. You're not going to be paying off any of the capital. Until after halfway through the mortgage, then eventually you'll start paying off more of the capital than you are paying off in the interest. So just bear that in mind. If you have to ever leave a mortgage early, you will end up out of pocket significantly compared to what you've paid in. The amount you've paid off of the mortgage will be very small until you start paying off more in capital. So this grey box here starts to get bigger than the blue portion there. So that's quite interesting to note. So yeah, that's another thing to be wary about with mortgage loans. So I've kind of gone over everything that needs to go over. In the event it's a variable rate, by the way, it's still the same equations, we just have to reset. So for example, in month 141, you take what you owe, you put it back in as the amount, then you take the remaining days for the duration, remaining months for the duration. So maybe you've got 6 years left, the duration reduces to 6 years, and you just change the interest rate to whatever they've changed it to based on whatever the factors that they use determines the interest rate, and it all gets recalculated. So there's nothing weird or dodgy going on. You can even in that calc change the interest rate as well. So you've got 30 years, 4.2%. Let's say after 5 years, so month 60 after 5 years. So we go to month 60. Month 60, wherever it is, if we can get to it. Too quick. Yeah. So after month 60, the interest rate goes to 6.3%. Let's say it's a massive increase in interest. We just recalculate. We'll have to drag all this down as well. So we'll drag all this down. Let's say it remains at that for the rest of the mortgage. The monthly repayment rate will jump from £978 to £1,214. So it's going to be a big increase in your mortgage payments, and you're going to end up paying a lot more. So whereas you were paying 35092, you'd be paying like an extra £70,000 more over the course of the mortgage, just because the mortgage rate has jumped up to 6.4% from 4 whatever it was. So yeah, and it might even change more than this. It might after another year change again. You just have to reset the value and recalculate going forward. On my spreadsheet, you can just change it when and as you need to. Every time you change a figure here, it will recalculate everything. So yeah, that's kind of I'll link this in below, and you can kind of mess about and play with this. But yeah, that's that's going to be the this video on the mathematical model behind mortgage loan repayments. The part that was linked to finite series was the part where we calculated for R, and we used a geometric series to do that. So thanks for watching these videos, and I'm going to be creating a new video series in the future. I'm not sure what it will be yet. If you liked them, let me know. I'll always try and do a long video on an application like I've done here, but I think with the amount of detail that I've gone into, it's worth doing just because it really drills the point home. It might be a bit too long for YouTube though, and it might put people off, and if that's the case, let me know and I'll try and slim it down in the future. But yeah, thanks for watching, and I'll see you in the next video series.